just take the interest times that number. It's an interest equation, but we're adding two things. And then what's the power? To the t, which is the number of, total number of years. In this case, if you get interest once a year, it's the number of years. If you got interest once a month, it's the number of months. But then you'd have a different interest rate. Because when they advertise interest rates, they advertise them for an entire year. So, certificate of deposit rates. So let's see what people are doing today. 13 best certificate of deposit rates for February of 2021. Boy, the internet is like a dog this morning. I can't believe how slow it is. Here we are. Okay. You recognize any of these banks? TIAA Bank, Consumers Credit Union, Penfeld Credit Union, Alliance, Discover, Alley. I don't recognize any of these. Here, TIAA Bank is doing a 1-year annual percentage rate of 0.5%. 0.5%. That's the best that you can just take money and put it into a bank account, but you gotta leave it there for a year, and you get 0.5%. Does that sound very good? No.
After a while.
So if you put in $100, what would you have at the end of the year? So if the rate is 0.5%, what's the R value going to be? Not 0.5. This has to be changed into a decimal. 2 places. 0.005. And then it'd be 1 year. So how much money is that? How much money would you get at the end of a year?
$100.05. Wait, no. Less than that.
We'll do it on a calculator if you need to. More than $100.05. $1.05. No, it's $100 and something. You see, this times this gives you your $100 back. That's how that works. So you have 100 times 1.005 raised to the first power, so you just multiply it once. It's $100.50. So a certificate of deposit, you get 50 cents back on every $100 in a whole year. That's not a lot of growth, is it? You'd expect to get more growth. Yeah, so CDs aren't very good. And you could do that. You go down to Alaska State Bank and you could do something like this. That's not very good. So that's why people put their money in other places. This isn't going to keep up with inflation. Your money would be worth less when you took it out. So what questions do you want to go over? Any, all, none? Did we go through a bunch of these in class at the beginning of the hour? We got through 10? Okay. We went through 10, huh? Did I really assign 10? I did. I'm looking at a different assignment. Golly. Internet, Google is worthless. It's not even loading this page. So what about 12 and 13? How did you set up number 12? wrote a number. Is that your final answer? So you wrote the 2.5% of 300,000. And when you change your 2.5% into the decimal, if you move the decimal point back to the place number, so you move the 0 in front of the 2, so the 0.02. At least make that much of a change, and then you come back to the rest of it. Where's yours? Where's the rest of yours? Looks like you're going back maybe on 10 to me.
I didn't line on every piece of paper, but I seem to have misplaced it.
That's not good. So you didn't go beyond. What should I do? It's hard to move forward when we don't make an effort at our homework. Okay, well, so number 12. So it says you deposit $300 in the new savings account paying an annual yield of 2.5%. It says if no deposits or withdrawals are made, how much money will be in the account at the end of 5 years? So what's the formula that we use to solve this type of problem? Okay, so what does P stand for? The principal. So in this problem, it's $300. So if this is the formula and number 12 in the book gives us the information, what should you write on your paper to show what you're doing for your work? Yeah, A equals, you substitute the value for the principal, and then it's 1 plus, what is R going to stand for in this case? 2.5%. Are you writing this? You should write, and you should keep up with this. And if we want to move forward, you guys, we've got to change the game a little bit. We've got to get after this, get us I don't want to talk all negative and everything, but if you have to do it again next year, you're going to be in a group of like 20 other kids that they all are really competitive and push hard. And that's not going to be a fun place to be. Having a group of 25 of you in a room or 26 of you in a room. So you have an opportunity here, but you gotta get up on your pony and ride hard. And if you're stuck on stuff, come in and get help after school. I sit here and twiddle my thumbs every single night. If nobody's here, I had 5 people in here, 6 people in here last night, but a lot of them were doing quizzes and such. Jonah's in here every single night. I'm in here every single night. Come in and I can help you get started on your work. But you gotta take initiative. So R stands for, what's the word?
Rate.
The rate, the interest rate. So if in the problem they say it's 2.5, we write that as a decimal. So how do you write 2.5% as a decimal number?
0.025.
Okay. Point. So So, and I write this up here, and if you don't remember that you have to move it back 2 places, you should write it in your notes and then refer to it when you're doing your work. Rather than, oh, I don't remember that. I don't remember, it's not good enough, because you're getting it up here so you can write it down. Use that as a resource. So here we have 0.025. And then what does T stand for in the formula?
Number of years.
Number of years. So in the problem, they say how many years? 5. So in your work, this is question number 12, this is what you would write. And then do what with it? What'd you do with that formula? Solve it. How? You gonna do it by hand? No. You're gonna take your graphing calculator. And you're going to type into your graphing calculator 300 times 1.025 raised to the 5th power equals, and you're gonna get an answer.
339.42.
Is that what you had written down? No, you had something close. You had 337, so you must have done something similar to this to get that close. So this is it, this is your calculator key sequence. I guess rather than putting a star, we can put an X with a box. 300 times 1, you add those together, raised to the 5th power equals. There it is. 13. What's 13 asking?
Bank advertises an annual yield of 4.81% on a 5-year CD, certificate of deposit.
Mm-hmm.
The CD's original amount was $2,000. How much will it be for after 5 years?
There you go. So another example of exponential growth problem. So again, here's our model to follow. Your total amount is going to equal, in this problem, what is P? How much is P in question 13? $2,000. That's the original amount. That's what you start with. So this is like a person walking into a bank with $2,000 and they say, here, I want to put this into a CD. And then that's going to get multiplied by 1 plus, how much is the interest rate?
4.81.
481. So we got to take 4.81 again and change it into a decimal number. So how many places do we move it back, Raven? 2 places. Once, twice. See, 4.81% means out of 100, so that's like a fraction over 100. And if the decimal point is here in 100, to divide the bottom by 100, we move the decimal point back 2 places. That's the same as dividing this number by 100. See, what you're doing is you're taking a fraction and you're writing it into an equivalent fraction, and this becomes over 1, and then this would be 0.0481. Move 2 places, move 2 places. So 0.0481. And what's the time in that problem? Leo, what's the time in the problem?
5 years.
5 years, so it's the 5th power. So now, what's the last step to do? Punch it in. So in your calculator, what do you get?
2,529.55.
Is there more than 5.5?
Yeah, but you said not to go past that.
Yeah, just cut it off, don't even round up, just stop. So this is that many dollars. So this is funny, so this book was written you know, what, 10 years ago roughly. And back then, CDs were in like the 4% or so, and today it's like 0.5%. The economy has changed. So how much people pay interest is based upon the strength of the economy. The economy is not very strong right now. People aren't giving you money to use their money because they have no place to invest it. There's not as many things to invest in the United States right now. So what's the next problem you had? 16 and 17. So 16. What are they asking?
Which yields more money? An amount invested for 6 years at an annual yield of 5%, or the same amount invested for 3 years at an annual yield of 10%?
So how do you think you can figure that out? I'm saying, what is going to give you more money? 6 years at 5% or 3 years at 10%?
Just put in an amount and everything in the equation.
Yeah, just put in an amount. So what's a nice easy amount to work with?
100.
10? Put in $10. So for 16, yeah, or 100, you put in $1, it doesn't matter. You're just going to do the calculation twice. So one of them is, let's use your $10, Raven. What's the interest rate and how many years?
One is 6 years at 5% and one is 3 years at 10%.
Okay, so this is the 5%, so what number do we put in for the rate? Six years at 5%. What's gonna go in here with the change?
0.05.
Move the decimal point 2 places. And then the other one is going to be $10. And how many years and what percent?
3 years at 10%.
Okay, so what number are we gonna put in here for the percent when it's a 10%?
0.10.
0.1. Yeah, we don't even need the 0 after it. 2 places. So, now what? Yeah, just calculate it. These are just number crunching things. You take the formula, you put the number in, and out comes an answer. What do you get 6 years at 5%?
13.4.
How much? 13.4. Okay, what do you get if you invest 10% for 3 years? Why aren't you guys doing your part on the calculators as well? I don't want to stand up here and just do problems for you. Crap, that's like you watching me mowing the lawn. Not any more exciting. But I guess if, I don't feel like I should have to be telling you too. I'm doing all this up here. You should be writing it down, doing it in your notes, practicing it. How much do you have? 10. It's times 1.1 to the third power, so that's going to come out higher than 10. Put it in the calculator again. You get the same number back? Well, you have 1.0. Not one. It's going to be 1.1. You have to add the 1 and the 0.1 together. How much does this come up to? You have 13 point what? 3-1. So which is a better investment? If it's your money, where would you put it?
At the 5% for 6 years.
Yeah, this will give you more money at the end of 6 years. Yeah, this is at 3 years. So what they're doing with this problem is they're showing us that a lower rate for a longer period of time is eventually going to catch up to a higher rate for a shorter period of time. That's what they're showing us. Okay, so let's talk rabbits. How many rabbits are in a litter typically? 10. Yeah, they're not like bears where there's 1 or 2 or maybe 3.
That's a lot.
There's lots. It's like chickens laying eggs.
What? Yeah, I haven't done it.
So rabbit populations go up really fast.
Yeah.
In a place like Australia, where they didn't have rabbits initially, they introduced rabbits at one time and the rabbit population got out of control because there are no natural predators. Here we have natural predators to rabbits. There's coyotes out there. There's maybe wolves pick up rabbits. Lynx probably pick up rabbits. Mink probably pick up rabbits.
Big birds.
Big birds will pick up rabbits, yeah. The hawks, the goshawks, some of the big owls will pick up rabbits. So our numbers don't just go on. You know, you can have 10 rabbits in a litter, but it doesn't just skyrocket. But if you don't have environmental factors, we start seeing growth, which resembles exponential growth. So here's the first example that they give us to be able to explain this. So not just money grows exponentially, but populations can grow exponentially. So they say 26 rabbits are introduced. So 26 rabbits are introduced or started with. And then they say that we assume that the population will double every year. So in other words, none of these rabbits are going to die. And, or at least if they do die, they'll be replaced with new rabbits. But it's not like, I shouldn't say they're not going to die. Their rabbits are going to die. But it's not like all of a sudden the population is going to level off where as many are being killed every year as are being reproduced. But it's going to double. So the population doubles each year for 28 years. How many are there? So if we have the number of years and then the number of rabbits, I think we could use N and R. Let me see what the book wants to use. They don't, that's okay. Let's do this. So in the first year, how many rabbits will there be? If at the beginning there are 26, after 1 year, how many rabbits? 52. After 2 years, how many rabbits? 3 years. 208. 4 years.
460.
Thank you for keeping up. 5 years.
832.
6 years.
1,664.
Okay. Do we want to keep doing this? No, we don't want to keep doing this. I mean, you could grab your calculator, right? Let's do this. Grab your calculator. Let me show you something out here. So on your calculators, type in 26 times 2 and hit equals. What do you get? $52. I'm gonna wait for these guys. So 26 times 2 equals, it's good. So that's straightforward, just 52. farm is Jackson. Jackson, you're not doing this, are you?
I'm trying to.
Don't. You can do that at home in your spare time. Grab your calculator. Both of you, grab it. 26 times 2 equals 52, have that on your screen. And then, just click times 2, and it should read answer times 2, and hit equals, and you'll get 104. And now just hit equals again. And there you go, 208, 416.
I'm just getting 104 every time.
Okay, so start all over. Do 26 times 2 equals. And then just do times 2.
All right, I got it now.
Equals. And you do this, and if you can count 28 times, you're gonna have a whole lot of rabbits, right? So the reason I had you do this with a calculator is because of this. To change from 26 to 52, what did we do? What was the math that was done to get from here to here? Multiply by 2. And then to get down again, we multiplied by 2. And to get down again, we multiplied by 2. So you may recall that I've shown you things like this before with linear functions, straight line functions, where it might be plus 4, plus 4, plus 4, plus 4, and that's part of the equation. Well, when it's times 2, times 2, times 2, what's happening is we're multiplying by 2 repeatedly. So as these numbers go up, we're multiplying by 2 that many times. So to get from here to here, to get from 26 to 52, we multiplied by 2 one time. Are you looking up here? And to get from 52 to 104, we multiplied by 2 again. So actually to get from 26 to 104, we had to multiply by 2 twice. To get to 208, we took 26 and we multiplied by 2 3 times. So what's happening is to get the number of rabbits, we are taking 26 and we're multiplying by 2 n times. This is our exponential relationship. So we take the beginning number and we multiply it by whatever our growth factor is. In this case, the growth is twice. And then how many times does the population grow is this right here. So in your book, they give the formula a little bit differently. And this is a pretty standard way of giving this formula. They say that, oh gosh, I gotta dig it up here. They say that y, and here's the y value, is equal to the beginning number. So this isn't the y-intercept anymore. Now b is the beginning number. So here's my beginning number, 26, multiplied by g. And g is the growth factor. So here the growth factor is times 2, it's doubling. And then we take that to the x, which is, in this case here, that's the number of times that the population, or the number that we have, grows. So let's define what all these variables are here. So y is equal to the ending amount. B is equal to the beginning amount. G is equal to the growth factor. Called a factor because it's a number that we use to multiply. And X is the number of growth periods. So, I guess I'll write down here. So here we don't know how long it takes, but we're just saying the population is double. And that's the exponential growth equation. Let me show you after you get that written down, I'll show you how that is pretty much the same thing as what we did yesterday, just written with different variables. You got that all? You have it all? You have it all? Okay, so yesterday's equation was this. The total amount was equal to the principal, the starting amount, multiplied by, this is how fast your money would grow. And this is how many times it would grow. So here, we have the total amount, the ending amount, the beginning amount, the growth factor, how the things grow, how quickly they get bigger, multiplied by how many times. So the formulas are the same, they have different variables, because the top one is thought of to be used more for money, and the bottom one can be used for anything else. You'd have bacteria growing. And you could, bacteria grow really, really fast if they're not controlled, if they're allowed just to keep growing and growing. And there might be a problem like that in our homework. So this is really important. Got it written up here. And then there's one more thing that's really important that you should include in this. I'm going to put it in the box up above. And that's what's called the zero exponent property. And the zero exponent property means that, or is described as this: if you have any number other than 0 for x, that number to the 0th power is equal to 1. So, but x may not be equal to 0. So if we look all the way back here, here's all of our calculations. This is 26 times 2 to the first, 26 times 2 to the second, 26 times 2 to the third. Well, this should be 26 times 2 to the 0th. So if I change color, we found this number by taking 26 times 2 to the first, 26 times 2 to the second, times 2 to the third, and so on. So way down here, n was going to be 26 times 2 to whatever n power it was. But now up here, this should be equal to 26 times 2 to the 0th power. And 2 to the 0 is the number 1. 1 times 26 is still 26. So the relationship, the pattern holds. And you may recall way back last year, I did something with you like this. Where 2 is 2 to the first, 2 to the second is 4, 2 to the third is 8, 2 to the fourth, 2 to the fifth is 16. So in order to go this direction, we have to multiply by 2 each step of the way. But to go the other direction, we divide by 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So if you count your exponents, it's 2 to the 0th. So we did it last year. If you wanted to keep going, 2 to the negative first would be 1 divided by 2, or a half. And we did that last year. Went up and down a number line like that. In fact, I bet we did it in 7th grade and in 8th grade. So there is proof of this. You can do it with powers of 10 or whatever. Example number 2 has us graphing the equation to take a look at what the graph ends up looking like. Do you think this is going to give you a straight line? No. Here, grab your graphing calculator. Let's put this equation in. 26 times 2 to the n. We're going to change that to x, so this becomes your y. So if you go into your y equals and clear anything that's in there. I think we had one yesterday. I can't remember what it was, but let's do y equals. And you're going to start with 26 times 2, and then it's going to be raised to the x power. So when you put that in, the x turns into the exponent. Are we there? But the thing is, when we graph this, look at these numbers are going to go crazy right away, aren't they? Because you're trying to, you're probably trying to graph something that's just crazy, so quit that. Let's look back at it. That's 2 times x. So it's got to be raised to, and, start all over, 26 times 2. Are you guys getting the raised to with the up arrow? Let's see your y equals. Enter it in, 26 times 2. Raised to, above the division. And then put in x. Go back, don't jump around. You spend too much time using your thumbs on games. Now x, xt, theta, n, next to the alpha green key. There you go. So there's your equation. Ooh. Your window was weird for that graph. It's okay, leave it. Let's change the window. How are we doing over here? You looking at the table? Can I see what you have in y equals? Okay, so yeah, you have to go back and see when you're in y equals, do you see up above it says plot 1, 2, 3, etc.? Do you see that across the top? You can turn those plots off to make your graphing easier by jumping up there with your arrow and hitting enter until it's not black when it's blinking. Do you understand? Raven? Jackson? Okay. Then I think what you need to do with your window is change your x. Make your x go from like 0 to, let's just do 6.
The x
Yeah, x minimum is 0, the x maximum. Let's just do 6. So we're just going to graph these first points. So then your y minimum goes from 0. What would be a good number to choose so we could get all of these points that I have on the board up onto your graph? 1,700. Do that, and then hit graph and take a look at your line. You get a nice smooth curve. You have points because you're still plotting your points. So go back to y equals. And you go up there with your arrow and hit enter to turn it off. Now hit your graph and you just have your points, or your line, I should say. Nice curve. See a nice curve? See? Yeah, so go back to y equals. Then we can hit quit. Second quit. Second quit. So like second quit like that. See the quits in blue? Oh, I don't know what's going on. There we go. Oh, really? So go to y equals. You see how you have plot 1 dark? Use your arrow to go up. Hit enter. Now that turns off that L1 and L2 graphing that you're doing. How do you say graph? Are yours working? Yeah. And yours is working?
Sorry, I'm so like,
What's better?
I'm not sure.
This one.
I did this one, it read the full class.
Getting sick of this?
No, I'm not sick, I just maybe I just need some water.
So So let's go back to your y equals. You got that in there, correct? Let's go to your window. Scroll down, change your y maximum to 1,700. 1,700. On your graph. There you go. Okay, so when we see graphs like this, we think of this as exponential growth. The slope is constantly changing. So remember the three populations that I showed you yesterday from the beginning of the chapter? There was no growth, a horizontal line. There was linear growth, the straight red line. And then there was that curve, which was a green line. Page back to that. This one right here. Page back, take a look at this. You see the green equation? It says 100,000 times 1.02 to the x power. So what they're doing is they're saying that this is 2% growth. Because what we do for this g value, this g is just like this right here. So if, for example, we had 100% growth, that's what's going on here. 100% more rabbits each year. That's 100% growth. That ends up being like 1 + 1 or 2 for the growth rate. So if you have a population that each year you have 102% of the previous year, that means you have 102 people for every 100 people last year. So this comes from these two numbers being added together. This is 1.02. If you change it into a percent, it looks like this. Okay, so your homework is to complicated set of numbers. 1 and 3, 5 to 7. 9, 10, and 11. 15, 16, and 17. Oh, I don't know. Do you mark your book?